Hello, everyone. Welcome to the AI tutorials. Today, we are going to talk about Convolutional Neural Network, or CNN. We talk about in detail about the different aspects about its architecture, what all goes into making this network. Since it is called as network, it should have more than one components. So what are those components? What do each component do, or how do they play the role in determining images? And what is its importance? We're going to talk about all about it. Now, CNN is a branch of artificial neural network. Its main application is image recognition. Like if you have an image, you want to identify what that image is, its application, convolutional neural network, is implemented there or used to detect images. It's a neural network. It mimics human brains. Now, if you look here at the human brain, we have various neurons connected with each other. That is how the information processing happens in human brain, right? Each neuron is connected with the other. This one is connected to this one. And this is how the information flows between different parts of the brain. And then in one area, maybe in the back here, let's say we determine or we find out, oh, this is this image. Oh, it is a flower or it is a sun or whatever it is. It's a road, it's a vehicle coming. So this is how the information process passes through from our eyes through different neurons and it gets processed somewhere in the back of the brain. Same thing happens here. Of course, it doesn't have eyes. It has an input. So this is just an example. So let's say if we are doing handwriting detection, right? There are various ways to detect if it's a fraud, like there's a signature fraud on the check, whether the handwriting really belongs to somebody, you know. So if we have, this is just a digit recognition. So we pass the image of a digit. So this is an image. Now this is a very simple image, no depth. It's just length and breadth, right? What happens is this image is divided into tiny, 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 tiny pixels. Like we have a matrix of pixels, which you'll be seeing in the next slide, which is passed as an input to the kernels. We'll talk about it. What are the kernels, what roles they do, or rather the neurons. Then there is pooling happening. Again, you have the kernel on the output of this one. So this pooling works on the output of this layer. This layer works on the output of this layer works on the output of this layer, and then it is flattened. And finally, there is this output. And then this output is connected with the actual results value. And then it says, oh, this output matches best to what? So it matches, the value matches best to 2, and then it detects 2. Okay. Now let's see. This is a basic architecture of a CNN. So you will have lots of layers. Each layer will have a filter or a kernel. Then the output of one layer will be used by the other. Then this is pooling. We'll see what is pooling. Results of the pooling is passed to the next layer, which detects something else. And then it detects something else. See here, tiny. So each part, one might detect this curve here because say 2 has a curve here. So one might detect a curve. One might detect this kind of curve. One might detect the straight line. One might detect this because each person writes things differently, right? So that is what, so and what makes it think, oh, this is not a 0, but it's a 2 because it has all the other features here, right? So this is how information flows. Now let's see each one in detail. So convolutional is at the heart of CNN, is the operation or a filter. Now when I say a filter, what it means is, now before I go ahead in the filter, see how the image is divided into different tiny, 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 tiny pixels? Okay, and then these values, these matrix values, are used by filters. Now what are filters? At the bottom line, everything is matrix multiplication. We're going to see an example. So a filter is a matrix. With matrix means it has rows and columns. Now, what matrix? Matrix of certain numbers. What are those numbers? Initially, they are randomly chosen and they are known as the weights. Weights in the matrix function. What happens is when you divide this image or the input image into tiny, 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 tiny pixels of, let's say, 3 by 3 or 2 by 2 or 4 by 4. Now, what are the numbers here? They make up the RGB values or of the image here, like whatever it is. And so here, see, the RGB value of this would be whatever the bluish gray value of RGB, and this would be pure white RGB value. So this is how the matrix will contain value. Filter matrix, the weights are randomly chosen at the beginning. What happens is you take this matrix, you multiply it by the filter, and you get the output. See, just the tiny, you get the output. Then you get the tiny, then the next layer uses its output, and then finally you get the mapped values. Okay, let's see what is what is a filter, what is pooling. Layers is different layers of the same thing. Okay, see, because it's not just one set of functions. Okay, then there are activation functions. Fully connected layer. We are going to talk about each one of them. Okay, so let's see. Now, what are filters? Let's talk about filters. They are the first one to work on an input. Okay, filters are also known as kernels, and they play a crucial role in feature extraction. What does this mean is, like, whether detect it's a curve, it's a straight line, and not just that, it's like what it is made up of. Some shapes need not be curves and lines. Some would be random, right? Something randomly drawn. If you take a picture, not everything would be straight line, right? Or straight curve. It could be a random anything. So they are small matrix weights that slide across input image. We'll see in the next slide what does it mean. Performing element-wise multiplication. So rather matrix multiplication, wherein one element of the matrix is multiplied with the other ones, and then you get the resultant matrix. And summing up the results to produce a single value. This process is called as convolution. And it helps the network identify meaningful features from the image. Okay, so at the heart of everything, it's the kernel, nothing but a matrix, multiplied by the matrix of the image. So, how filters work in CNNs? The size. Filters are typically very small dimensional arrays, 3 by 3, 5 by 5, focusing on a small area of the image. Each filter, there are multiple filters. So each filters operate on one or multiple channels of the image, say for RGB or something like that. Weight values, as I was talking about. Each element in the filter matrix represents a weight. Like for a curve, how much weight should be given? Determining, see, if you're using a CNN which is designed for handwriting detection, it might not work perfectly with identifying, or it might not do that good of a job in identifying a real life picture, like a rose or say a car coming in, because its training data is different, right? So therefore the weights which you decide would be different. Okay, the importance that you give to each feature of the image. Now, what is a feature of an image? It means nothing but, say, if there is a sunlight, let's say if it's just a photograph, if it's there are stars and there are trees, birds, they're all features of the image. If it's handwriting, whether it's a cursive handwriting, whether it's a straight handwriting, whether it's typed, so these are the features. Convolution, which means the filter slides across the image. Again, just bear with me. In the next slide, I'm explaining that. Slide across the image with a certain stride, moving by 1 pixel or 2 pixels at a time, and then doing multiplication and computing its weight. Output, when you do matrix multiplication, you get an output. And some of these multiplications for each become a single value output, which is called as a feature map. Now, as mentioned earlier, CNN has multiple features within each layer, each used for detecting a different feature, like edges, shapes, textures. And then by analyzing the activation of different filters at different positions, the network learns to identify and combine these and finally give a educated guess that what this image could be about. So basically, in short, filters or kernels are nothing but small matrices of 3 by 3, 5 by 5, having first to start with, it has random weights assigned. See here, this is the example. Okay, now here, this is an example of pooling. So now this is a next layer, okay, of it. So what happens is, let's say here there's a weighted matrix, okay? Supposing we have a 4 by 4 feature map. Now this is a map, what you get after multiplying, matrix multiplication. So if this is the output of the matrix multiplication looks like, what you would do in pooling is you would take a 4 by 4 map. Okay, now not necessarily you have to take 4 by 4, but that's minimum, like you say 2 here, 2 here, right? In a matrix, when you call a matrix, because this, if you take just 1 by 2, it becomes an array, right? So you take 2 by 2 or a 4 by 4 feature map, okay? Now in that, we apply a max pooling of say 2 by 2 window, horizontally and vertically. So what you do is take this 4, this matrix of 2 by 2, what is the highest value in it? 2. So you get 2. Take this 4. What is the highest value in this? 4. So you take the 4. Take this unit. What is the highest value in this? It's 4. So you get 4. Take this matrix, 2, 1, 0, 2. So what's the highest value? 2. So you extract, you give importance to the feature or the weight which is most significant. So that is pooling. So if we go back here, so first what we did, we took the image, we divided it into tiny matrices. We chose multiple filters. Filters nothing but multiple matrices. Each pixel of this multiplied by that matrix, this pixel multiplied by this pixel multiplied by this, and it produces an output. From that output, we pick the most significant feature, which is called pooling. The output of that pooling, if you see here, the output of the pooling is again a matrix, which again serves as a input to the next convolutional layer. So that is how, which means this will again be divided by another filter, a matrix multiplication filter. Okay, and then again the output will be used. So this process continues. There are multiple layers depending upon how complex your image detecting algorithm or the AI thing you want it to be. So see here, so after the max pooling, so what happens? See here, we are come to the minimum size. It is a continuation from here. So max pooling. So your 4 by 4 matrix is reduced to 2 by 2. Okay, so which means it helps improve computation faster, giving importance to the most significant features in the image. Now here the resulting 2 by 2 represents the output of applying max pooling. Now look at this image here. It is not a simple handwritten image, right? This image has multiple objects in it. It has depth. If you see the picture when it is taken, these flowers, now we are going to the next concept. So these flowers are closer to the camera. This is a little bit inside, this is a little bit inside. We can see, our eyes can tell, like there are two trees here in the background. Okay. Now there is a bench here. Now this could be empty, or there could be somebody, a person sitting here, or an animal sitting there. Anything could be here. Or there could be a dog here hiding, or some animal hiding here. So multiple features in the image, right? Activation functions are used to identify these non-linear characteristics of the image. They are called as non-linear features. The depth, the color, like if you see each one, this is a different color, this is a different color. These are not all red roses, right? See, these are pink. Some of them are slightly white, the different shades of green. Okay, a bench, and a bench has something written on it. Complex features, right? Activation functions, or what are those? They help the network to identify these nonlinear features. And the most popular activation feature is ReLU, which is rectified linear unit. So, say for example, transition from light to dark pixels along the edge. Okay, it's a nonlinear feature. Edges, textures, they are all complex features. Activation functions help the model identify them. Now, say example here. Supposing we have a 3 by 3 matrix here. So do you see after computation, there is some negative values. ReLU is the most simplest form of activation function. What it does is, it takes a matrix. If the value is greater than 0, 0 or greater, it leaves it as it is. All negative values, it replaces it with 0. That's all, very simple. That's an activation function. So that what happens is, we pay attention only to the features which were maximum weight, or which means which are very significant in that tiny area of the image. So element-wise matrix, it's simple. Function fx is equal to max of either 0 or the number. What it does is, in short, it replaces any negative value with 0 while leaving the positive values unchanged. So see here, this 3 by 3 matrix is converted after applying the ReLU function as this. All the negative values are replaced with zeros. So we talked about kernels, which is matrix again, multiply it. We talked about pooling, which is again matrix, where we take. So there is max pooling, and then there is average pooling also. Average pooling in the previous one. In max pooling, which means you take the maximum value. Then there is average pooling. Average pooling, what it does is takes the average of all the 4. So here it would be 4 and 4, 8. So average would still be 4, right? 8 divided by 2. So it takes the average of all the numbers and then does it. So that's average pooling, max pooling. Max pooling is the simplest. It takes the max of all the 4 and uses it, or the matrix dimension. Activation functions, it's very simple, helps you detect complex nonlinear features of the image. The most widely used one. Then there is also sigmoid function, which is an activation function, which is different. So what is different? The formula. So at the end, what is an activation? It's a function. Whatever you choose, max is either 0 or x. This is an example of it. How, if you were supposed to use it, how you would use it. CNN, an image detection program in Python. you are going to use TensorFlow library. So pooling, see 2x2 pooling, dense. Now what is dense means? Dense is when one layer is fully connected, or rather when one neuron is fully connected with all the other neurons, it is this. Now what is a neuron basically? Excuse me. A neuron itself is nothing but a function. At the end of it's all mathematics. It's function. That's why we have all the matrix multiplication and everything. So at the basic, each one is nothing but a each one of this is a function. Excuse me. Sorry. And now this is very dense because each neuron, you can see, is connected with all the others. And when a neuron is connected with every other, it is called as a dense network. You can choose not to have a neuron connected with all the others. Say this one could be connected with only this. You could have that. So here you're defining a convolutional layer, 3x3 matrix. You're giving it the activation function, input shape, which means the input image coming is in 32 by 32 by 3. Height, weight, and depth. So that's the input matrix coming in. Pooling, you're going to use 2x2. So which means for every 2x2 output of the previous layer, you'll pick the max number because it's a max pooling. Then again, the next convolutional layer, again pooling, again convolutional layer. So you define 3 layers, 3 convolutional layers and 2 pooling layers. Then you flatten the layer, which means convert all this matrix into a single dimensional array, one dimensional array. And then you define the density, which means again, every neuron is connected to the other. And then your model is done. You compile the model, you train the model with training images. Now here you're using some data set, training data set. And then you evaluate the model with test images and you test the accuracy. So this is in a very simple, plain language. What is CNN? Okay, or how does the image detection work in artificial neural networks? So brief recap, neuron or what the term it is, nothing but a computation unit or a function. Image is divided into matrix. Each matrix is multiplied by a filter or a kernel, which is again nothing but a matrix. Weights are randomly chosen at first, and then what happens is, if the output differs from the actual one, you go back and change the weights. Keep on doing back and forth until the model detects the correct image or comes to a very close enough guess. Now going back and forth, back again to go and adjust the weight from the first layer, okay, or the filter weight is called as backpropagation, which means you decide, so let's say the filter, right? 2x2 filter. You take some random values, 46, 32, 1, 5, you multiply it. And then it will produce or it will guess something at the end layer. And if the guess is wrong, then you go back and change the matrix weight. Okay, this is called as backpropagation. So these are some concepts about CNN. Hopefully your understanding is clear. After this, any questions, comments, please feel free to write it and I'll try to answer them. All right, thank you for your time. See you all again in the next lecture. Bye.